Okay, so let us look at problem C. Okay, so this is our next problem that we are going to focus on. So the question is given, problem C. So we have natural log of natural log of x plus y equal to xy minus y cubed. Okay, so we want to find the derivative, which is the first derivative of this problem. Okay, so what do we do? So as you can see, we have y appearing on both sides of the equation, right? And we have y in each term of the in this equation. So we cannot separate y from this, right? We can't make y the subject of formula at this point, isn't it? So what are we going to do to find the dy dx? So we're going to use what we call implicit differentiation. Okay, we're going to use what we call implicit differentiation. So what does implicit differentiation say? So if you have x and y, right? Okay, let's say it's a sum of these two or the product, whatever it is, right? Since we are taking the derivative of this each term with respect to x, okay, so means that if we take, for example, you want to find the derivative of x, so you're taking the derivative of x with respect to x, right? So this just becomes a 1, okay? Just differentiating x with respect to x. What of y? So the derivative of y with respect to x, right? So this is simply equal to what? 1 times the derivative of y with respect to x. So every time you're using implicit differentiation, when you see a y, just take the derivative of that, okay? But don't forget multiply by dy dx. So that's a secret, okay? So let's dive into this. So what we have here, we have two sides of the equation. We have the left-hand side as well as the right-hand sides. So we're going to differentiate each one of them separately. So just a recap, how do you differentiate natural log of, let's say, u? Because of natural log, we still have to take note of that, right? So the natural log of u, its derivative becomes what? U prime. So you take the derivative of what you have inside divided by u itself. Okay, so for example, if I have natural log of x squared, so you're going to differentiate x squared, which is 2x, divided by x squared, right? Which is 2 over x. Great. So this is exactly what you're going to do here. Now, how are we going to differentiate natural log of x plus y? Since we have a sum of these two, right, terms. So let's start with natural log of, let's say we have q is equal to natural log of x plus y. So I'm just calling this term here q, right? It's okay. So here we have this form. We're going to say, okay, let u is equal to x plus y. Okay. So we have to, every time you let something, you have to find the derivative of it, right? So what's the derivative of u? So bu prime or du dx. Remember, we're trying to take this guy, but we are trying to find the derivative with respect to x, right? So this will be equal to, what is the derivative of x with respect to x? Just like I said, it's equal to 1, right? Plus, what's the derivative of y with respect to x? So the derivative of y is simply 1, but don't forget multiply by dy dx. So we're going to have 1 multiplied by dy dx, or simply just dy dx. Okay, so meaning that our q is simply equal to natural log, okay, sorry, natural log of u, right? Because you said let u is equal to x plus y. So again, you can take the derivative of q, right? So what is the derivative of q? Derivative of q, so dq, remember what, doing this with respect to y, okay? So dx, and this is equal to, okay, so let me just q prime, right? Let me just say take q prime. So q prime will be equal to 1 over u. Just like I said, differentiate the guy inside there, divided by over u, isn't it? Okay. All right. So now let us put everything together. So q prime, which is the derivative of this function whole thing, right, is equal to 1 over u. Okay, 1 over what was our u? Our u was x plus y, but we're using chain rule. Remember that we also have to include now this guy, its derivative, right? Okay, which is the u prime, multiplied by u prime, isn't it? Or du dx. So this is equal to what? Okay, so this is 1 over x plus y multiplied by u prime is simply 1 plus dy dx. Okay, so this is our derivative of what we have the right hand side of the equation. So every time if you have natural log of, let's say, x whatever, let's say it's, let's say you have natural log of let's say it's the, let's say you have x to the power whatever m plus y to the power m. This just becomes what? 1 over x to the power m plus y to the power m multiplied by the derivative of this guy here, right? Okay, you drop it by power, which is n, x to the power n minus 1 plus m y to the power m minus 1 and then dy dx. Please take note of that. Okay, so that's how it is, right? So if you have natural log of whatever plus whatever inside here, x power whatever, y power whatever, just do this: 1 over n plus 1 over x power m plus y to the power m multiplied by the derivative of each, right, inside, right? So this is by power rule, and then you differentiate y, don't forget including dy dx there. That's the shortcut way of doing things, right? Okay. All right, so let's do that. So that's a derivative of what you have to the right hand side. So I'm going to say, for simplicity, I'm going to say dy dx is simply equal to y prime. I don't want to be writing that dy dx, it's very long. So it means that our q prime, the function to the left, is simply 1 plus y prime divided by, okay, x plus y. Okay, so we have this as our derivative to the left hand side, right? The equation. Now, what about the right hand side? So I'm going to call the right side hand side as p. So p is equal to xy minus y cubed, right? So I have to find p prime. So p prime is equal to, as you can see, of two functions here. That's a product, right? So we're going to use what we call product rule, isn't it? So what's the product rule of this? How did we show that? Remember, product rule, if you have u multiplied by v, both of them are functions. Okay, you're going to say u prime v plus v prime u, right? Okay, so differentiate one while keeping the other one. Okay, so first of all, I'll take the derivative of x, which is simply 1, while keeping y. Okay, so this will be 1 times y, just be y, plus, secondly, I'll keep x and find the derivative of y. Remember, every time differentiating y, don't forget dy dx. So the derivative of y is simply 1 and then multiply by dy dx. So this just be dy dx minus the derivative of y cubed. This is simply equal to 3y squared, but don't forget dy dx. Okay, so just a minute. Okay, so this is what we have, isn't it? So remember that dy dx, I'm representing this by y prime. Okay, so this becomes y plus x y prime minus 3y squared y prime. Now I'm going to equate these two now. P prime, q prime equal to p prime, right? Because I've just taken the derivative of both sides, so I'm just equating them. So remember, our q prime was 1 plus 1 plus y prime equal to, sorry, over um, x plus y, and this is equal to our p prime, which is y plus xy prime minus 3y squared y prime. Okay, Now remember, we have to make y prime the subject, because we're trying to find the y dx. Remember, y prime is simply dy dx. So I'm going to take cross multiplication here. So 1 plus y prime is equal to, I'll multiply this, x plus y multiply by this other side of the equation, y plus xy prime minus 3y squared prime, y prime. So let's distribute. Remember, we're trying to solve for y prime, isn't it? So of 1 plus y prime equal to, so x times y, that is xy, plus x times xy prime, that is x squared y prime, minus, this will be 3xy squared y prime, right? So I done with x. We'll do the same thing with y times y, that is y squared, y times xy prime, that is plus xy prime, minus y multiplied by that, that is 3y cubed y prime. So remember, we need to solve for y prime, isn't it? So I'll take every term that has got y prime to the left hand side, and then remove everything that doesn't have y prime to the right hand side, isn't it? Okay, so y prime remain here. I'll get this guy minus x squared y prime. What else? This will be plus 3x y squared y prime. Okay, what else? Minus xy y prime, and then plus 3y cubed y prime. I think that's it. Equal to, here we only have y squared and the xy. This guy didn't cross, and then one had crossed as minus 1. Okay, so let's factorize the y prime. Factorize that, we have 1 minus x squared plus 3xy squared minus xy plus 3y cubed, right? And this is equal to y squared plus xy minus 1. Okay, so we divide both sides by this guy here, so that we have y prime equal to y squared plus xy minus 1 divided by 1 minus x squared plus 3xy squared minus xy plus 3y cubed, I think. Okay, so please make sure that you check. If there's any mistake, you let me know in the comment section. Okay, so for now, I'll say bye bye and thank you for watching. God bless.